All right, we've got Algebra 2, OAS A2818. Student will solve systems of linear equations using the elimination method. You also hear this called linear combination. We'll call it elimination because that's what the book calls it. The student will solve systems. That means we're going to have more than one equation, just like we did when we were using the substitution method. We'll have more than one equation. We're going to solve it using the elimination method. Lecture 324 and 325. Here are the steps we're going to follow. We're going to make the coefficients of either variable exact opposites. The coefficients are the numbers in front of the variable, like 2x, 2 is the coefficient. We're going to run through these, and I'll go through these as I'm solving. I'll be referring to this. So when you hear me saying that, saying the things I'm saying, this is what I'm talking about. I'll scroll up and point to it every now and then. But here are two things that we're going to run into today that we didn't run into over the last 2 days. I said we would get to this in 2 days, and with the next lecture, well, here we are. If you're doing these steps up above, and you notice that all of the variables disappear, that means there's no solution. If you're doing everything that you should do, and all of a sudden all you've got is a statement like, for instance, 0 equals 9. If what you're left with after the variables disappear is a false statement, that means there are no solutions to the system. This is true for what we're doing today and what we've done for the last couple of days with substitution. Okay, so we're going to run into it. I'll show you how it works today, but it also applies to substitution. If you're doing everything you should be doing and you haven't made any mistakes, and both of the variables disappear and there's a true statement left, for instance, 0 equals 0 is a true statement. If that happens, then there are an infinite number of solutions, okay? So there we go. These are the situations we're going to run into today. And we'll also run into a situation where there's just one solution. So there could be one solution, no solutions, or infinitely many solutions, an infinite number of solutions. Those are our three possibilities. We're following these steps. Here we go. Make the coefficients of either variable exact opposites using multiplication. Here's what that looks like. I've got this equation right here. I'm looking at these variables. The x's, I could make these exact opposites by multiplying this one by -2 and by multiplying this one by 3. They would both turn into -6's. But here's an easier one. If I just multiply this one by 2, it's the exact opposite of this one. So that's what I'm going to do. I'm going to multiply this by 2. And in order to do that, I've got to multiply every term in this equation by 2. That way, the value of the equation stays the same. So what I'm going to do is I'm going to multiply this one by 2, which means I'm going to have to multiply everything in this equation by 2. When I get done, I'll have 4x plus 4y is equal to -8. Then I add this equation to this equation. That's the next step. So I'm going to just bring this down. I'm going to rewrite it down here just so visually my eye doesn't have to jump up and down so much. Okay. So what I've done so far is I've made the coefficients of either variable exact opposites. Now I'm here. I'm going to add the equations together. I'm adding this equation to this equation. This equation is the original equation. Here I made this one the exact opposite of this one by multiplying everything by 2. When I add these equations together, look what happens. I've got 7x is equal to, what is that, -21? They're the same sign, so I add and keep the sign. And then the next step says solve for the single variable. So I'm going to divide both sides by 7. That's what, when I say the next step, I'm referring to these. Step 1, make the coefficients of either variable exact opposites by multiplying. Add the equations, that's what I just did. Now I have an equation in one variable, so I'm going to solve for the single variable. That's where I am. So 7x is equal to -21. I'm going to divide both sides by 7. And I've got one of the variables. X is -3. 21 divided by 7 is 3. One of the numbers is negative, so the quotient is negative. The next step up there says plug this value into any equation you want. Pick the simplest one. Well, neither one of these is any simpler than the other. So I'll just randomly pick one. I'll take this, you can plug it into any equation as long as it has to have two variables in it. I'm going to take it and I'm going to plug it in right here. You could plug it into this one just as easily. I'm going to say 3x minus 4 times negative 3 instead of y. Oops, my bad. I plugged it into the y and I just found a value for x. So ignore that, I got to plug it into x, not y. See what I did? I was going to plug it into the y value to x value that we found. So I'm going to plug it in here. Pardon that. And I could just as easily plug it into this value. So here we go. I'm glad I caught that early. This gives me 3 times negative 3. 3 times negative 3 minus 4 times y is equal to negative 13. And then we just do a little bit of arithmetic and solve it and we'll have our y value. This is negative 9 minus 4y is equal to negative 13. My plan is to add 9 to both sides and then divide both sides by negative 4. So I'm adding 9 to both sides. This is negative 4y, this cancels. Negative 4y is equal to, what is that, negative 4? They're different signs, so I subtracted, kept the sign of the one with the greater absolute value. Now I divide both sides by negative 4 to get y by itself, solving for the other variable. This gives me y equals negative 4 divided by negative 4 is 1, positive 1. Now I write my answer. I'm at the very last step that says write your answer as xy ordered pair. Write your answers as an ordered pair, xy. Well, I found x and I found y, so I'm going to write my answer as negative 3, 1. And hopefully that's my solution and I haven't messed it up. I'll look for my answers and see. Negative 3, 1. Negative 3, 1, yay. So I just followed those steps. If I were me, and I am, I would pause it right here and write these steps down in my own hand. So I'd have them right there next to me. And then I would proceed to do all the problems on the worksheet after watching this lecture. Let's do another one. I'm going to run through these steps up above and hopefully not make a mistake like I did on this one. Make sure you plug the variable into the right variable value into the correct variable. Step 1 is make the coefficients of either variable exact opposites. I said, well, I can make this the exact opposite of this by multiplying it by negative 3. So that's easy to do. That's what I'm going to do. I'm going to multiply this entire equation by negative 3. That way it doesn't change the values in the equation. It's just multiply both sides by negative 3. So this gives me negative 9x minus 21y. That's supposed to be an x right there. That looks like a y. That's supposed to be an x. So I'm distributing this negative 3 right here. And I got negative 9x minus 21y is equal to negative, what is that, 27? And now I'm going to add these two equations together. The next step says add the two equations together that have exact opposite coefficients. I'm going through those steps up above. So this gives me 0x, which is 0. Look at there, there's 0y. That's another 0. Is equal to 0. So I've got 0 plus 0, which is 0. 0 equals 0. This is one of the situations I told you to watch out for above. If you have a true statement, this is either true or false. If this is true, which it is, then that means this system has an infinite number of solutions. And we're done. Oops, see if I can spell infinite. Infinite number of solutions. Or infinitely many solutions. Okay, that graphically that means if you graph this and you graph that, one of them will lay directly on top of the other. We call that being coincident. They'll occupy the same space, so to speak. Okay, so there are infinitely many solutions. And that was this situation right here. If there are infinitely many solutions, both variables will disappear. See how they both disappeared? 9x minus 9x is 0x. 21y minus 21y. I don't have any x's or any y's. 0 plus 0 is 0. And the statement is true, so I have infinitely many solutions. Okay, let's do another one. I look at this one and say, okay, I can make these exact opposites by multiplying this one by 2. I can make these exact opposites by multiplying this one by 2, so that I'm going to multiply both sides by 2. This will give me negative 16x plus 6y is equal to negative 10. I'm just going to bring this equation down to add them together. I could add them right here, but my eye would be jumping around. I don't want to do that. So I'm just moving this one down here by rewriting it. Okay, so I multiplied, made the coefficients of either variable exact opposites, and now I'm going to add the equations together. I'm following those steps up above. I'm right here at this step. Make the coefficients exact opposites using multiplication. I'm adding the equations together, and I'm going to solve for this single variable. So here we go. Adding these together, this gives me 0x plus 0y. Looks like this side is 0 again. My variables disappeared. I don't have any variables. Equals 1. 11 minus 10 is 1. This gives me 0 plus 0 is 1. That's a false statement. All of my variables disappeared and I'm left with a false statement. That means that we interpret that to mean that there are no solutions to this system. Graphically, what that means is if we graphed both of these lines in the xy coordinate plane, there would be no point of intersection. So that means that they would be parallel to one another. They'd just be zipping right along next to each other. They'll never cross each other, so there are no solutions. The solutions are the points of intersection. Okay? If the lines are parallel, there are no solutions. Alrighty, so we found one that had a solution. We found one that had infinitely many solutions where one line lied right on top of the other. We found one that had no solutions. I don't have any idea what this one's going to have, but let me make sure this one had no solutions. Make sure I'm right. No solution, yeah. Well, let's take a look at this one. I want to make the coefficients of either variable exact opposites. And I see that if I multiply this one by 2 and multiply this one by 3, that'll be negative 6 and that'll be 6. I could multiply that one by 7 and multiply that one by 5. That would be 35 and negative 35. So I can do either one of those. I'm just going to do this one just because. I got to do something, so that's what I'm going to do. I'm going to multiply this equation by 2. That'll make this negative 6. And multiply this equation by 3. That'll make this one positive 6. So the coefficients of the x's is what I'm going to change to exact opposites. Whatever happens with everything else, I really don't care. I'm looking for the solution of the system. I want to make sure while I'm talking that I don't make a mistake. Saying one thing and writing another is where I make a lot of mistakes. So here we go. I'm multiplying this one by 2. That'll give me negative 6x plus 10y is equal to negative 44. Now I'm multiplying this one by 3. That gives me positive 6x. That's what I was shooting for, to get the coefficients of either variable to be exact opposites, and I chose x just randomly. Minus 21y, make sure I'm not messing up, is equal to, what is that, 66? That's step 1 done. Step 2 is add the equations together. My x's disappear. So this is 0x. You can put 0x if you want, but it's just gone. Now I add these together and I'm going to get, what is that, negative 11? Y is equal to 66 minus 44 is 22. Now I'm at the step that says solve for the single variable. Now I have an equation instead of having 2 variables. This variable didn't disappear, so I can solve for it by dividing both sides by negative 11. By dividing both sides by negative 11, I get y is equal to negative 2. I can then plug this in anywhere I want. So I'm going to plug it in right here and solve for x. I've solved it for y, so I'm plugging it into y. Here we go. solving for x. This will give me negative 3x plus 5 times negative 2 is equal to negative 22. That's the equation I'm plugging it into, just this original equation in black. And now I'm going to solve this for x. This is, let me scroll down just a little bit. Negative 3x minus 10 equals negative 22. I'm going to add 10 to both sides. Negative 3x is equal to negative 12. I just added 10 here and turned to 0. I added 10 here and got negative 12. Now I'm going to divide both sides by negative 3. That'll give me x is equal to, dividing this by negative 3 would be negative 12 divided by negative 3 is positive 4. And so my solution in alphabetical order, 4, negative 2. This is the ordered pair that will make both of those original equations true. If I plug in a 4 here and a negative 2 here, I believe that was my solution. Yeah, 4, negative 2. If I plug in a 4 here and a negative 2 here, this equation will be true, the original black one. If I plug in a 4 here and a negative 2 here, this equation will be true. And if I graph both of those, they'll intersect at this point. Okay. That's the elimination method. You can do this. Follow these steps. Write them down in your own hand. Take your time. Elimination. Those are your steps.